Hello everyone, welcome to this session, part of Global Azure event organized worldwide today. We will talk about Azure Stream Analytics and machine learning, AI, and everything around it, but I would like to share some information about local event in Bulgaria in advance. Because of long holidays in Bulgaria, we will have local hybrid event next week. It will be exceptional, not at the same date like all other sessions as now, today, tomorrow, and on Sunday. We have most of events worldwide, but you will have also interesting program in Global Azure Bulgaria next week. So I will like to share some information about this event before to start. So I would like to say thank you to local partners of this event, and really we will have very interesting event in 3 tracks, 2 in person and online, and 1 remote only online next Saturday, 14th of May. And if you are in this region, you are welcome to join this event in person. If you are in another location, feel free again to learn something more about Microsoft Azure next Saturday. But now we will be focused on Global Azure 2022 Global Stream and about this session, which is related to integrating Azure Stream Analytics with Azure Machine Learning in a nutshell. My name is Mihail Mateev. I'm a volunteer and enthusiast, part of Bulgarian community, mostly focused on cloud computing and data platform, primarily with Microsoft technologies, but also open for any open source projects in general. I'm very happy that we continue to drive these events also in Bulgaria and support the global initiative. I'm also part of Microsoft Insiders Group, like Regional Directors Group and Most Valuable Professional insider groups in Microsoft, and also I hold PhD on cloud computing. Now we will talk more on how and in which way we can make this integration between artificial intelligence and the most popular streaming service in Microsoft Azure, data streaming service, Azure Stream Analytics. We will talk also a little more on IoT, because scenarios where we use Azure Stream Analytics more often are related to data injection, data transformation in close to real time, which is pretty typical for IoT. Of course, you can use this technology to many other solutions. Just IoT is one of the typical domains, and also IoT is my passion. That's the reason to have more of samples related to Internet of Things. We will have some details about main patterns where we can use Azure Stream Analytics, and also how to use Azure Stream Analytics with machine learning, cognitive services, and any kind of artificial intelligence related technologies. We will talk a little more on anomaly detection, and at the end we will have some demos. That's the plan of this session. one more time, huge thanks also to global organizers of this event with the support of Microsoft. Probably most of you are quite familiar with Internet of Things, at least from consumer perspective. And it is obvious that number of connected devices is growing very fast. Pretty soon, any device will be connected via internet to some backend services and will send some data for analysis, and will be possible to receive some commands and notifications from backend services to be possible to reconfigure this device, to optimize their behavior and other tasks. IoT is one of the most popular trends in current industry. And IoT is related to almost all business domains nowadays. It is not only to manufacturing, automotive, and scenarios where most of people consider such technology. Now you can use Internet of Things for almost everything, including also scenarios for fintech, from insurance, healthcare, and pretty soon you will have no domain from global industry where IoT is not involved. We will talk mostly on data streaming and especially functionalities related to Azure Stream Analytics in the context of Microsoft Public Cloud, Microsoft Azure. Microsoft Azure is the main object of this global Azure event. And I like to say every time Azure is a moving target. It is, of course, true for every platform, especially cloud platform. Microsoft Azure is probably the most fast growing cloud platform last several years, and Microsoft Azure is improved and it is continuously changed platform where you have new functionalities, optimized existing functionalities. What we are talking about Microsoft Azure and related services now can be very, very different in the next years because platform is staying more developed, newer services are added, everything is working more effective, and you can see additional functionalities. So in cloud computing, everything is considered for relatively short time, like actual state, and what we are talking now probably will be actual for next 1-2 years. After that, platform can be much more developed with new services, and we can do the things probably also in different ways. What we need to know about general context of IoT and especially parts related to our context, data processing. IoT solutions have several main areas. We have devices and device connectivity. We have data processing and analytics. This is exactly the area related to data streaming and data transformation, and we have presentation layer. This part where data is visualized in one or another way. These are tightly connected parts, and we need to consider everything like one common platform. Just data processing and analytics are the part which is up to data and which is the main focus related to this presentation. I will add some information about general components without going a lot in details. Probably most of you know that we have different devices in modern Internet of Things, devices with separate addresses where it is possible to have direct reference to these devices IP in your network. It is possible to have also devices which are not designed to connect directly to cloud backend and existing cloud gateways like Iot Hub. And for these devices, you need to have gateway services which transform protocols supported from these devices to protocols supported from the platform, especially supported from the gateway services. And one important component related to our case is Cloud Gateway. Cloud Gateway is the service which provide communication between devices and IoT platform backend services. There are different options for Cloud Gateway services, and in Microsoft Azure, as probably most of you know, Iot Hub is the component which provides fully functional support of all functionalities needed to have secure, stable, scalable IoT Cloud Gateway. Cloud Gateway reroute information or data to stream processors. Stream processors are services which are used to transform data in real time, or more correctly said, close to real time, because always there is some small delay. So probably real time is not the best match, but very close to real time, probably with some small delay, few seconds after data is sent. This data can be already processed in backend services. For stream processors in Microsoft Azure, the most popular, efficient, and probably also the simplest one option is to use Azure Stream Analytics, the main subject of this session. Regarding to Azure Stream Analytics, we have specific details which we will discuss later in this presentation. Stream processors are responsible for three things: to ingest data from some input. Quite often this input is directly Cloud Gateway or Iot Hub, but it could be different service which is related to message distribution, or it could be also some storage. Stream processors also are responsible for different types of data transformation, including also external or internal call of analytics related functionalities, and stream processors are also related to output of data to different storages or other services. And it is possible to have at the same time these stream processors not only for data processing, but also for connection between different components. Iot Hub provides fully supported integration with Azure Stream Analytics. Azure Stream Analytics by default can read input from Iot Hub, and you have no need to consider special configuration for this. Iot Hub has several types of interfaces. We have no time to go into details, but one of these interfaces is related to communication with backend services, and exactly in this part, Azure Stream Analytics use this interface to establish connection for input from Iot Hub. When we talk about stream analytics, we have many different use cases. Now we will consider mostly patterns related to Azure Stream Analytics, like exact implementation, to be more clear what is possible to have and where you need AI capacity in such kind of situation. You are able to have complex event processing from different inputs. For example, you can have input from Iot Hub. It is possible to have also other services related to event management and processing, like Event Hub, and it is possible to have several inputs and to manage data from these several inputs in a complex way in your stream analytics service. Output can be in different way. Output can be directly to analytics and BI related platform like Power BI. It is possible to have real-time dashboards where you can see data in real time based on input from Azure Stream Analytics and functionalities supported from Power BI. In such situation, when you have Power BI and when you have Azure Stream Analytics, it is possible to consider analytics functionalities in two different places. Azure Stream Analytics, where we will discuss later about different options for data transformation, and also analytics functionalities of Power BI. When we talk about live dashboards, usually most of analysis are done in Azure Stream Analytics, and Power BI is mainly related to presentation functions. But again, you can make some data filtering and transformation also in Power BI. When we talk about other types of scenarios where data is stored in separate database, and you have options to use it via Power BI, we can have scenarios where analytics functionalities for Power BI can be also efficiently used together with functionalities which we have in Azure Stream Analytics. Let's see the next scenario. I already started to talk about this scenario where we have complex event processing, several sources, and we have data persistence into database. When we have such scenario, we can have already persisted data after transformation in specific output storage, database or storage, and we can read already transformed data from presentation layer and analytics tools like Power BI, and we can have several different phases of analysis. So such scenario can cover many different use cases. In this case, we can have scenario where we do not consider from where is data, but it is possible also based on some specific properties to have analysis which are based on filtering of data sources. The difference is that in the first scenario, you have no need of data persistence. Quite often, we need presentation of data without need to keep this data for a long time. In IoT solutions, usually you have several types of storages. You have storage which is for raw data. Usually we need to have raw data for some period of time to be possible to apply on top some complex analysis. We store process data in separate storage. Usually we have some aggregations there, and this data is not in this amount like raw data. And we can have some data used just for very short time, live data, like this first scenario. It is quite often seen to have scenario where actually Azure Stream Analytics make transformation, make complex events processing, and after that you have the next phases related to different services. It is possible to have eventing platform. It is possible to have event grid and to have push notifications to other services if something is happening. It is possible to have output to specific HTTP endpoint, web apps, or Azure functions. It is possible to have output to Azure Service Bus or different alternatives. In any case, you can support possible scenarios, even if your output to specific type of service is not supported, because with Azure Stream Analytics, you can have HTTP endpoint for output, and it is possible to use web service or Azure functions in two different ways with specific logic inside it, or just to make clue between Azure Stream Analytics and other services. Quite often, we have scenario where we need custom real-time visualizations. What means custom real-time visualizations? If we have Power BI, live dashboards, Power BI is very powerful platform, but it is a platform where by default you have some functionalities possible to be used easy and pretty fast. If you have very custom scenarios, additional customization can take much more effort, and in this case, it is possible to have custom real-time visualizations and to use, for example, Stream Analytics with SignalR service, and based on such approach, you again can have push notifications. It is possible to have scenarios where you have stream analytics, persistence into different storages, and you can have after that real-time applications which consume this data from these sources. It is possible with solutions like Azure Cosmos DB, for example, to have also change feed. Based on change feed, it is possible to have event-driven design for specific applications. So Sometimes pretty similar use cases with small differences can be implemented in a flexible way using Azure Stream Analytics and other Azure components. Often we can have several steps of data transformation. It is possible to have complex event sources and analysis based on several sources. This analysis will generate output which can be used after that from several different processing services, data processing services. Can be again Azure Stream Analytics, like most obvious solution, can be, for example, another streaming service, and after that, again, you can have some databases, supported change feed, and you can have real-time applications based on event-driven design, which will make some updates when there is new information in the change feed. It is possible also to have some scenarios where you are using reference data. Reference data is very important if you need from one side to enrich your data, your messages which you collect. You have no need in optimized solutions to keep all information for your messages during the whole workflow from generation of these messages to the end. The generation of messages can be done in a way where we have optimized structure, less data, and less not often change data. When data is arrived in the backend, it is possible to enrich these messages with additional data, with reference data and also with other sources. Reference data usually is updated not so often based on some analysis or based on information from other applications. And in this way, you can have reference data based on already processed messages, which is also up to date because reference data is updated from different applications when you have some period of time. It could be scheduled, it could be based on different logic. It is possible also from Azure Stream Analytics to call machine learning functionalities. Here we have more closer to our main subject scenarios. It is possible to do this in several different ways. It is possible to have cognitive services or publish machine learning models, and to have HTTP calls. You can raise directly Azure function from Azure Stream Analytics. It is also possible to have specific direct calls to publish machine learning models. It is relatively new functionality, and it is possible also to use some embedded AI functionalities. I mean, embedded in Azure Stream Analytics on the level of API and SDK. Behind the stage, you have some analytics services providing, for example, anomaly detection and some other types of analysis. Let's see options for integration of Azure Stream Analytics with different types of AI services. It is possible to implement user-defined function, and this user-defined function can actually be used to call machine learning models in your Azure Stream Analytics. This is one of the possible options. For this option, you need first to prepare your machine learning model. You need to configure it in a specific way and to test it that this service actually can accept specific JSON serialized data and to receive also such kind of specific data. There are templates in Visual Studio Code. You are able to create such kind of functionalities there. And you need to have specific input parameters to be possible to call using these user-defined functions your machine learning models. This is the overall idea when we are calling with user-defined functions published machine learning models using Azure Stream Analytics. This functionality is available for the last year. It was for some period of time in preview, and you need to know more details. Learning curve here is not so small, but if you are fine to take attention of this, actually you will be able to have very good integration between Azure Stream Analytics and machine learning models. If it is not possible to spend this time, there are other options, and we will talk also on other opportunities. One of the most important for IoT functionalities is related to anomaly detection. Anomaly detection is also integrated into Azure Stream Analytics, at least partially. We will talk about this. And we will talk also why anomaly detection is so important. Because most of scenarios where we collect some data is to have predictive analytics, to predict if something can be happen in the near future related to some fail or work downgrade of our solution, and we need to prevent this, taking some actions in advance, and in this way to save a lot of money. What is important when we have predictive analytics? Quite often, predictive analytics is related to another group of analytics methods related to anomaly detection. Why? Because based on anomaly detection, we can realize if some values from our data are quite different than others, more than usual, and we can classify based on different algorithms these values like some anomalies. Based on these anomalies, we can have additional analysis, which is in the scope of predictive analytics, and to try to analyze where is the potential issue, and of course, if it is localized, to try to have some action in advance. About anomaly detection, we have two group of analysis techniques: multivariate anomaly detection and univariate anomaly detection. Univariate anomaly detection is related to one time series. I mean, we have one source, one type of data, and we are looking for some anomalies exactly in this time series. It is good for many use cases, but usually it is not possible formally to apply such kind of approach without additional analysis and to understand that we have some anomalies in a complex solutions where you have different time series. You have data changed in time from different sources. For complex solutions, it is possible to use multivariate anomaly detection where, based on different timelines, to try to find in this complex solution some possible anomalies, but using directly algorithms related to anomaly detection. Again, the difference is that when we have univariate anomaly detection, we can have such kind of analysis for specific timeline, but after that, you need to have additional logic to be possible to apply this information in the right context. We will consider more univariate in our cases because it is easy to present and understand this. For multivariate anomaly detection, we need to have different scope like timeline and much deeper presentation in the near future. Anomaly detection can be related to different cases, from climate change, via manufacturing, automotive, healthcare. You can make possible to analyze some changes not usual for specific group of data, and in this way it is possible to initiate additional logic to discover what is not as you expect. When we talk about anomaly detection, we have also several options in Microsoft Azure. From one side, you can do this with Anomaly Detector service, which is part of Cognitive Services, Azure Cognitive Services. This Anomaly Detector service has two interfaces, one for univariate anomaly detection and another one for multivariate anomaly detection. It is pretty easy to start to use it. To integrate it with other services, you need to use a similar approach as when you need to have integration with any kind of cognitive services. You need to have actually created instance of this service. You need to have API key and endpoint, and you need to have to learn on the basic level API used for this analysis. It is possible to apply different analyses when we have multivariate time series anomaly detection. You can have up to 300 different signals. For multivariate time series, we have something like this, and we need to realize what is not usual considering together all these time series. It is possible to have also similar implementation on the level of machine learning, but for main cases, it is not payback to consider custom models when you can use anomaly detector service. It is also possible to have some of these functionalities as part of embedded functionalities for Azure Stream Analytics, and we will see details also related to these cases. But going back to Anomaly Detector service, we have Anomaly Detector API, Anomaly Detector service supports REST API, and internally, this service is choosing specific algorithms. You have no need to know about this. Usually such services are considered as options for people who have no need to go deeper into AI algorithms. Of course, very skilled professionals also can use it because they will save time. In documentation, you have good explanation about different type of algorithms and logic used in anomaly detectors. Anomaly detector, depending on API, is receiving one or several time series. Let's consider Univariate to simplify the case. These series are classified, and based on classification are used different algorithms. So we have first phase of extraction of data, selection of algorithms. Here you have a pretty formal approach. It is not related to business context. It is just related to data. And you can have also some adjustments of these algorithms and filtering of your data. When we talk about Azure Stream Analytics and what is possible to use as capabilities, it is also important to know that Azure Stream Analytics is available not only on the cloud, but also on the edge. It is possible with few clicks to generate in Azure IoT Edge instance of Azure Stream Analytics, which will be deployed on your edge devices. In reality, this instance is container providing some functionalities, but this instance also use cloud resources. Transparently for you, you have no need to know a lot about this communication between Edge, Stream Analytics, and Azure resources. It is possible to have also in Azure Stream Analytics option to call directly some functionalities related to AI and especially related to anomaly detection. I will show you now what exactly is up to anomaly detection and Azure Stream Analytics regarding to embedded functionalities in this service. It is possible to have spikes and dips in your data, and especially for this part, anomaly detection functionalities in Azure Stream Analytics are more than enough. You have no need to create separate services. Even for cognitive services, you need to support additional service in your infrastructure, platform-based, but again, you need to have communication. It is more than a few clicks and just calling of this service. What is possible? It is possible to have in your Azure Stream Analytics jobs calling of functions which are related to spike and dips. For example, in this example, for your data, you have anomaly detection, spike and dip, and you have here your data. You can put the percentage of confidence, so you are able to provide control for this exactly percentage of confidence, 95% in this example. And it is possible also to put here the number of events which are considered like history. Why? Because you can have flexibility in this way. More events are for the longer timeline. Sometimes you need, sometimes you don't need, depending on timeline specifics. You can have different understanding for the spikes and dips, and from another hand, you can have different time, different resources, like computing resources in general. This reference to the cost regarding to options which are you using. It is possible to have from one side, let's go back, also change point. Change point is when you have just change of your normal data in a way where you will just have shifting of the values up or down. It is possible to have also scenarios where you have, for example, continuously changing the values, and after that you have a change point which will move in one or another direction your normal values. Change point, anomaly detection change point is another type of analysis. And you can apply this analysis in a different way, because spike and dip is something which is for the momentum and specific timeline. Change point is when you have just change of the trend, for example, or you have shift of your data like range in specific moment. What you have in such kind of analysis, you have again timeline, but timeline is related also to units, for example, minute and number of units. You have confidence, and you have history depending on number of events. What will happen if we have not overlapping here? For example, if we have too many events or too small number of events, here the smaller one will be considered. If we have, for example, 10,000 events for 20 minutes, that means you will consider maximum timeline, which is set with number of events. This is the most important. It is possible also to have partitioning on the functional level here, and you can consider several things. For example, your duration and history size, depending on what you want to have. If you have different overlapping, will be possibly manage using different partitions. So you can have several partitions if you have, for example, differences between timeline and number of events. To be possible to have considerable number of events per partition for the specific timeline. So this is probably the most important, which I wanted to share because we have limited time. Now I will try to share several demos. For us, first, I will make a reference to Microsoft Azure portal. I will show you the following situation. I already created Azure Stream Analytics service, and in this Azure Stream Analytics service, I have input, which is from Iot Hub. I will show you additionally details about this. I have output. This output currently is already configured in Power BI. Now I have here options to test it. We have all depending on what we need, it is possible to need to make change of authorization. I will demonstrate a little bit later. And we have queries. This query is already prepared. I just put here sample similar to this one, which I show in the slide, related to anomaly detection for spikes and dips, and put these parameters 29%. Even we can change it. For example, 90% of confidentiality. We can make number of events different. For example, doesn't matter, and depending on what we want. And we need to have also different duration. We have additionally several things. We have, let's save this. We have Iot Hub. In Iot Hub, we have already registered device. This device is ID Anomaly Detector Simulator. I already added here credentials which are needed for establishing of connection, and I have sample device simulator. Additionally, we have into Power BI portal, we have service with credentials here. What is needed? It will be needed to add, for example, some specific workspace connection. Let's try to fix our Azure Stream Analytics connection for Power BI. in the output if it is needed. We can check, for example, if we have some problem here, it's possible to make the things in a way where let's try to make the things yes, it is possible to do it, for example, in one or another ways. Now I'm trying to add authorization. I do this outside of shared screen. It's possible so yeah, it seems that now it will work. What we can do using this approach, I have actually two different samples. First sample in Visual Studio demonstrates how you can do anomaly detection calling directly Anomaly Detector service. And this is actually what you need to implement calling some web service or Azure functions from Azure Stream Analytics. Here I'm showing the logic related to calling of Anomaly Detector service. For example, you have call to specific service or function where you need to have your time series like timestamp and value, and you can have also several additional parameters for control related to units and some other things. And actually, Anomaly Detector service will receive response where you can have detected anomalies or not. But in our case, I will use device simulator, which is needed for Azure Stream Analytics sample. So I will start this device simulator and need to add several credentials. Here for our Iot Hub. Give me a second. What is needed when we go to Iot Hub? Sorry. You need to copy hostname. Of course, in real sample, such kind of information will be automatically added. You need to have something like this. And you need to copy device key. Device key is not directly visible, so I am able here to show this. Also, give me a second. Second for this. So we need to get keys for the devices. Yes, I need to get it from devices. Devices. And to go to, for example, AD simulator, to copy one of the keys. And here you can have, for example, spike dips. We can have different level of these. We can make it in specific time, and we can start this simulator. It will work such way. We can change this, making duration smaller, for example, or something like this. To be possible, let's make it example smaller interval, something like this, and we can start. What additionally we need to have? We need to update, not to update, but to run, sorry, our Stream Analytics job. Let's try to run it. Usually, starting of Stream Analytics requires several seconds, not to 3, probably 30, and in specific moment, you will see, based on metrics, that you will start to receive some information. For example, input events, and after specific time, we will start to receive this information. Just it requires a little more time. So the idea is that we will have here also check of number of events. Our Stream Analytics will start to process data, and in Power BI or into another output, it is possible to see the results of this analysis. Let's just go back to metrics to see if we already have these events. Unfortunately, it requires more time. We are time boxed from existed schedule of the conference, so I will be able to provide additional information to everyone of you if you are interested to more details related to Azure Stream Analytics and AI capabilities. If you have any questions, feel free to contact me via social networks or email. I will be glad to help you. And don't forget, we will have also local event in Bulgaria, exceptionally not at the same days like global event, but next week. Thank you for attention and enjoy the conference.